Kick off the recording.
We have a lot of new people. Hey Priya, hey Chris, Dixon, how are you guys? Ankit.
Hi, welcome
Hi.
everybody.
Hi. Hey Patrick, hey Arshad, pleasure to be here.
Thank you for coming. We really appreciate it. So, just waiting for 2 secs. Right. So is this the 15th or the 16th?
16.
16th. Right, welcome everybody. I've forgotten, I should remember. To the 16th weekly community community meetup for the Decoding Data Science and AI group. I'm your joint host, Patrick, with Mohammed Arshad, and we'd like to welcome everybody. Today we have an amazing talk by an old friend of mine, Javier Ideami, and I just want to welcome everybody to join. We decided to change the routine a little bit today. We're going to dive straight into Javier's talk. So I'm going to introduce him. Has he got the ability to share his screen, Mohammed?
Yes.
Okay, so let me introduce Javier first then.
Yes.
Javier is an expert in AI and deep learning, specializes in advanced visualizations, computer visions, and generative architecture. He's a multidisciplinary engineer, researcher, creative director, artist, and entrepreneur. He's an old friend of mine from 30 years ago, I think now, Javier?
Yes, a bunch of them.
And projects have taken him from Silicon Valley startups to the jungles of Bali, working with Stanford University, UC Berkeley, United Nations, the Financial Center London, the International Cultural Diplomacy Conference in Berlin, and many, many others. Some of his projects, the latest projects, are the Geniverse, one of the world's first generative AI problems, the LL Explorer, a tool to explore lost landscapes of deep learning optimization processes, Lucy, which visualizes the parameters of neural networks in real time. He has a film about to be released called the Hamelin 77, which is about prompt engineering using generative AI techniques, and how that in the creation of a movie, and also what the movie is all about as well. He speaks at conferences all over the world, master's programs. He has one of the most successful generative AI courses on Udemy with over 20,000 students. And he has many different articles and things that he's posted. Whilst Javier's talking, I'll be posting all his links into the chat here, so you can go and explore what he's up to. But for now, I will hand over to you, Javier. Thank you very much for joining us. It's lovely to catch up with you again. Please begin.
Thank you, Patrick. It's really lovely to catch up with you as well again and to meet again. And I really thank you, Mohammed, and thank you, Patrick, for organizing this event. And congratulations for everything that you're doing in relation to, education and making people aware of all things AI. With an international community that you have in your group. So very exciting to do this talk for all of you. Let's go for it. So I'm going to share my screen. Let's see if this works. So in theory, let's see. I've just clicked the button, and if nothing fails, you should hopefully see the slide now. Okay, can you see the slide? What can you see?
Yes, we can. It just popped up. Yeah.
Yes.
Yeah, but there is one thing that is not working correctly. That is the resolution of the size of things. I think it's. Let me see 1 second. Something is not working well. Yeah, it's like something is not going well. My computer is going a bit crazy. Yeah, it's like it went out of the screen sharing has stopped because the external display is disconnected. Oh. Okay, I think something happened with my graphic card. So let me see. Maybe you can keep talking about something else while I check to see what's going on here. Yeah, because something has happened with my graphic card. Let me see.
Okay, hold on. Don't worry. We have plenty of time.
Okay.
Mohammed, do you want to?
May I go back in to reset it, probably?
Yes.
Yes. Yeah. Yes. So I just give couple of minutes. Javier is just fixing his sharing, then we will start.
You can chat about what's been going on this week, maybe.
Yeah. So yeah, till I think when you're ready, let me know. So I can. Yeah. So basically, this week we have been we had a workshop specifically about EDA, right? Exploratory data analysis and using some statistics. It was a very interesting session. It was a very different data set I took. I took a cricket data set, which was a little bit interesting. It was a real data from the cricket league. So you guys were discussing football, we were discussing cricket. So some of the participants, they did not know about cricket. Someone was from Colombia. You should have come, Patrick, there in that session. There were some people from Colombia, I think Chris also was there. So we explained about cricket, the data set, and then we used Python to do a basic exploratory data analysis. And then we were talking a little bit about statistics in that, because in an EDA, we have to use statistical techniques. And it was an interesting conversation. The time was short. We could not go in details about the correlation. We discussed a little bit about correlation, but we could not go into categorical variables, the chi-square, the association between the categorical variables. So these were the things that are happening. We have since the last week, because we had plans of few events that are going to happen this coming week. We have a session on OneNote by Hemant. He is one of the career coaches where Chris had talked about OneNote, so he volunteered to talk about how we can use OneNote, how we can be a little bit productive in using OneNote. And that session we're having on the 1st of September. And all the details are there. I'm sure you all are part of the nas.io platform. So all the events are getting updated there. And also we have an SQL training, because at the end of the day, data science is very, very important for artificial intelligence. So we are all are talking about AI, but data science we have to understand. And also we had an interesting conversation about all these stuffs in the group, about the latest things that are happening. Chris mentioned about something that the Meta has launched recently. There's a lot of things are happening. There is a tool that I was exploring that Meta has launched for something like a code interpreter, which is it is good. It is good. Still, not spend a lot of time in that, as there are a lot of you can say AI tools that are there, but we have to see what really works for us. So that is one thing that I tell people. There are a lot of AI tools that are there. Try to take a use case that you have and try to use these type of tools that can really help you, and also learn more about LLMs. So coming about LLMs, we are actually we are planning to do something. So LLM is a very hot topic right now, but there is a lot of things that we need to know before we start using LLMs. So maybe I will when I'm doing the weekly update details after Javier's presentation. So he had some technical issues, so he has just, I think Patrick has
He's
just
rebooting
started
his computer at the moment, so.
Okay. So till then, so these are the things that are happening. We are giving the summary. We are giving the summary of the event, the things that are happening. Let me just quickly also look into it and let you guys know.
Okay, I'm back.
You're back. Okay. Can you try to share your screen? I think not.
Yeah, let's try again. Let's try again.
Yeah.
See what happened. So, okay, let's see if this time it works.
Yes.
Okay, so you can see now.
Yeah.
Now it is good. Yes.
Perfect. Okay, I hope when I do a slideshow is still going to work. Let's see. Oh, I think this is the problem when I click a slideshow. You can still see?
Yes. Yep.
We can see.
Okay, perfect. Let's try it. Struggles a little bit, but you can see everything is good. Okay, so I'm ready. When you give me the signal, let's begin.
Go ahead.
Go ahead, begin.
Okay. Hi, everybody. It's a big pleasure being here for this presentation, Tower of Mind from ChatGPT to AGI. So what we're going to do during this presentation, and we're going to try to wrap it up in around 35 minutes, maximum 40. Okay, so we're going to begin by talking about two different ways of processing information in your brains and our brains, the fast and the slow mode. This is important to understand because after that, we're going to talk about ChatGPT and about what are the limitations currently of ChatGPT and what kind of, as example, what kind of hacks we are doing nowadays to try to overcome these limitations, okay? And after that, we're going to speak about the way forward, what kind of new architectures we could produce in AI to overcome these limitations for real, and not just hacking our way through them. So let's begin. Okay, you already did the introduction, but yeah, I'm Ideami, I'm Javier Ideami, and I'm involved in AI from many different perspectives, producing and developing platforms like Geniverse, doing consulting, doing research like with the Lost Landscape project, doing interactive productions like Totem, or movies that involve generative AI like Ameline 77, giving conferences and talks, speaking at master's programs, television, creating courses. Anyway, from every possible perspective almost. If you want to know more about me, you can just go to ideami.com and there is like a very simple index there. Okay, let's go for it. So Daniel Kahneman, Nobel Prize Daniel Kahneman, in the last years has popularized a lot these two ways of processing information in our brains in his very famous book, Thinking Fast and Slow. And these two ways of processing information in our brains, we could say they are the slow mode, we have the snail there, and the fast mode, we have the cheetah there. And the way to explain these two modes, the slow one, he calls it system 2, and the fast one is system 1. System 1, system 2. We could call them something else, but nowadays it has become very popular to speak about system 1, system 2. So what is system 2? System 2 is when we are facing something completely new, a new situation, a new scenario for which we don't have a response pattern already learned that fits with it. And we have to learn a new response pattern. We need to learn the steps of a new algorithm to deal with that new scenario and situation. And for that, we need to focus consciously, paying attention, and go slowly. That's why it's the slow mode. Go slowly, step by step, finding the steps to solve this new situation in a sequential and systematic and logical way. And that is system 2. But what is the problem of system 2? The problem of system 2 is that it spends a lot of cognitive resources. Using system 2 is tiring. It spends a lot of energy. So we cannot be using system 2 all the time. So what we do is, once we have learned a new algorithm, we want to transfer it from the conscious to the subconscious. We want to automate it, make it automatic. And so what we do is we transfer it to the fast mode. And what is the fast mode? System 1. System 1, basically what it does is to map very quickly from a perception or from a state of the world that is a compressed perception to an action. It's basically perception, action, very fast and quick loops of perception, action, without having to activate all of that machinery of slowly looking for the steps of a new algorithm. So it's a very fast way to automate what the system 2 learned previously. System 1, system 2. Now, some people say, but why do you have these two systems? Why don't you call them something else? I mean, it doesn't matter how you call them. The important thing to understand is that there is a very obvious, common sense way of understanding why these two systems exist. So any organism, if it has to face dangers, if it wants to survive, if you have a tiger in front of you, you don't stop to reflect and think, oh, how should I act now? You don't have time to do that. You need to very, very quickly map perception to action, super quickly. And that is system 1. So system 1, it just makes sense that every organism has to have a system 1. Now, ideally, because system 1 is very cheap, it spends little energy, ideally, all you would have is system 1. That would be perfect. Then you would be like an automatic zombie, you know, but it would be very cheap. The problem is that that doesn't work, because when you are facing something completely new, for example, you want to learn to drive for the first time, or you want to learn to play a piano piece for the first time, you don't have a response pattern in your brain that fits with that, because you've never encountered it before. So you need to learn in a different way. Now you need to slowly paying attention, you need to look for the specific steps of a new algorithm, of a new method to find the solution to that new situation. And that is a completely different way of thinking, and that is system 2, okay? And now, so first of all, as a summary, system 1 is intuitive, fast, subconscious in humans, parallel, non-linguistic, habitual, implicit knowledge, blah, blah. And system 2 is slow, logical, sequential, conscious in humans, linguistic. It has to do with planning, reasoning, etc., etc. And now we're going to connect all of this with ChatGPT. So what's happening with ChatGPT and most AI systems today? That really what they have mastered at a superhuman level is system 1. Basically, they are very powerful at doing pattern matching. Basically, they are very powerful, subconscious connectors in a way, And they have. I always put this comparison of the human subconscious as a cooking pot that is mixing and combining and recombining things, and you have to think about these AI systems as these massive, much larger, pots that are able to combine and recombine way more ingredients and way faster. And in terms of system 2, well, there is some controversy. Some people think that systems like ChatGPT don't have any system 2 capabilities. Other people say that they may have some rudimentary, weak models of the world, system 2 capabilities. You see, to have system 2 capabilities has a lot to do with having a good model of the world. What is a model of the world? Because we're going to look at this later. So a model of the world means that if you want to do reasoning, if you want to plan, you need to consider the future, what we call counterfactuals. If you want to consider the future, you need to be able to simulate in your mind things like the consequence of taking some actions, or you need to be able to predict what's going to be the next state of the world, what's going to be the consequence of taking some actions. You need to be able to complete or fill in some missing information in your perception. And if you want to have all of this, what do you need to have in your mind? You need to have a simplified abstraction, representation of how the world works. And that is a model of the world. For example, a map of Europe in paper is like a simplified representation of the surface of Europe, So in the same way, a model of the world in the mind is like a simplified, abstracted representation of how the world works. So some people say that ChatGPT doesn't have any model of the world, and other people say that probably it has some rudimentary, some weak form of model of the world, very different to our models of the world in our minds, but it probably has some weak version of it. But that is still very far from the from a very robust and efficient model of the world like we humans have. So mainly what they are very good at is system 1. And system 1 is analog to our human intuition. It's always on, always active. You look at a face, you look at a place, and there's always an interpretation that your system one gives you very quickly. It maps that perception to some feeling or some emotion or some conclusion or interpretation. And sometimes your intuition is very good, but sometimes it makes very silly mistakes as well, which is what happens with ChatGPT. ChatGPT is very impressive, but sometimes it hallucinates, sometimes it lies, sometimes it tells you very silly things and very contradictory things because it's very similar to the human intuition that is system one. So what we're doing today is we're using a number of hacks or tricks to try to overcome the fact that ChatGPT is very good at system one capabilities, pattern matching, but is very weak at system two capabilities. And let me tell you now some examples of these tricks that we're using with ChatGPT. And after that, we're going to see what could be a type of future architecture in AI that could fix these problems. Okay, so very quickly. ChatGPT and these LLMs, they have zero-shot prompting. It means that just because of their training, there are many skills and many things that they are capable of performing without having to give them examples or anything. It's just because of their very expansive training. For example, you tell ChatGPT, classify the following text as positive, negative, or neutral, and you give it a text. I had a really amazing trip, and you say feeling ... and it tells you answer positive. So it is classifying that text without you having to train it or fine-tune it or give examples or anything. This is zero-shot prompting. But many times, zero-shot prompting is not enough. It doesn't work well. And then you move on to few-shot prompting, which means you are going to guide the large language model, ChatGPT, with examples. And this is the beginning of what we call prompt programming. You are programming ChatGPT through prompts. And so you want to classify a text between being ambiguous or clear. Is ambiguous or is not ambiguous? And you give it some examples. You say, look, not sure if it's suitable. This is ambiguous. Of course, this is clear. Well, if you say so, this is ambiguous. Blah, 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 blah. You give a number of examples, and at the end, you ask a new thing. You say, I'm with you, and it answers clear. Okay, so it has taken your examples as the guide, and then is applying all of that to a new question successfully. But sometimes few-shot prompting is not enough. Then we move to chain of thought prompting. And here is where we are going to start understanding how we are dealing with the problem of ChatGPT not having good enough system 2 capabilities. In chain of thought prompting, we are guiding the LLM by explaining the steps of a reasoning process. This is a more advanced form of prompt programming. So we have a question, and I'm going to give you a very simple example. It would be better to give a longer example, but it would take 2 pages, and we don't have time for that. So very simple example. Pedro has 7 tennis balls. He buys 3 more boxes of balls. Each box has 4 balls. How many balls does he have now? And you're going to explain it the way that it should reason its way to the answer. Look, Pedro started with 7 balls. 3 boxes each with 4 balls are 12 balls. Then the answer would be 7 plus 12, 19. This is what you give to ChatGPT. You give this to ChatGPT. You say, this is the example of the reasoning. And now you give a new question. The stall has 20 pairs. If they use 15 to prepare a cake, blah, 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 how many pairs do they have? And then it answers. This is the answer of ChatGPT is at the bottom, is the yellow part. And what it's doing is imitating the reasoning process that you gave to it. And really what's happening here is that you are telling ChatGPT, listen, ChatGPT, you are very good at system 1, but you are really bad at system 2. Don't worry. I am going to use my system 2 as a human being. I'm going to use my system 2. I'm going to devise the steps of a reasoning process. I'm going to do it with my system 2. And I'm going to give to you those steps of the reasoning process. And you just have to imitate them and apply them to a new scenario. And that's what happens. And ChatGPT takes the steps that you gave as an example of that reasoning process and applies them to the new question successfully. Yeah? And the style had 20 pairs, and it reasons in the same way that you did, and it gives you the correct answer. So that's the way we're going around it. That's one of the ways. Now, another way. Sometimes it's not so easy to devise these examples of reasonings for ChatGPT. So another thing that you can do is zero-shot chain of thought prompting. This is very simple and very amazing that it works, because you prepare the very same question than before. Pedro has 7 tennis balls. He buys 3 more boxes of balls, same question, but you add something very simple at the end of it. You just add, let's think step by step. That's all. You just add that. Let's think step by step. Nothing else. And what this provokes is that ChatGPT, instead of trying to use, let's say, system 1 in a very brutal way, let's say, just by trying to find a match between the entire question and another thing that many times doesn't work very well, what it's going to try to do is to try to do it more gradually. It's going to try to split the process in different parts, okay, and try to do those, that matching in a more sequential way. So it's a way of trying to imitate the sequential nature of system 2. Again, it's a hack, but sometimes it works very well, not always, sometimes. Okay, now very quickly, some other options. There is automatic chain of thought prompting. Sometimes creating these examples of reasoning, it takes a long time. So there is a way to basically use ChatGPT to first produce examples of reasoning using the previous technique, and then take those examples and do the pure chain of thought prompting as before. This is self-consistency. We go towards more advanced prompt programming techniques. This is very interesting. What you're going to do is you're going to create a tree of possibilities. In chain of thought prompting, we only explored one possible, we only gave one example of a reasoning process, and we let ChatGPT work. But now we're going to do the same thing with multiple ways of, multiple examples of reasoning processes related to the question. And we're going to do this multiple times like a tree through different branches. And at the end, we're going to pick, of all the answers that ChatGPT gives, we're going to pick the most consistent one. That's why this is called self-consistency. This is very, very interesting, right? It's like we are combining the continuous with the discrete. We are sort of making a heuristic discrete search on top of the continuous work of ChatGPT. It's a more advanced form of prompt programming. All right, generated knowledge prompting. This means that sometimes ChatGPT doesn't answer very well because it doesn't have enough context about the topic. So you can first go to ChatGPT and you can tell it, go and explore this topic and give me like general examples of it and information. And then it gives them to you. And then you prepare the final prompt by combining that general contextual information with the question that you want to give, all of that together in one prompt. And sometimes that works better. Okay, this is a very, very nice technique, very advanced. That is the tree of thoughts technique. Again, it's another way of trying to replace the limitations, the system 2 limitations of ChatGPT in a very clever way. We're gonna try to build the reasoning steps of in response to a question, but part by part, gradually through a tree of possibilities. So we tell ChatGPT, this is my question. I want you to give me different possible first reasoning steps for this question. Only the first step. You say, I only want the first step of this reasoning for the answer, but multiple options for it. And it gives you multiple options. And now you do something incredible. You tell ChatGPT, I want you to tell me from all of these options that you gave me for the first step of the reasoning, which one is the best? Incredibly, this works really well because for artificial intelligence systems, it's much easier to classify than to generate. And it makes sense. When you classify, you are working with much less options, a space that is way smaller. And when you generate, you are working with a much larger space of possibilities. So you ask ChatGPT to generate multiple options for the first step of the reasoning, and it gives them to you. And some are going to be better, some are going to be worse. And then you use the same ChatGPT itself to critique and to judge which one of those is the best. And it works. And it tells you this one is the best. And then you take that one and you tell it, okay, great. We're going to go through this part of the tree. Great. Now I want you to give me, again, multiple options for the second step of the reasoning process. And it gives you multiple ones. And then you are, okay, now critique them for me. Which one is the best? And that way you are walking through a tree of possibilities with the help of ChatGPT. And if through one of the branches ChatGPT doesn't like any of the options, you can go back in the tree and go through a different branch. Okay, and this works really, really well. And again, conceptually, what we're doing here is we're telling ChatGPT, you are not very good at system 2, don't worry, I'm going to help you. Okay, we're gonna walk together. We're gonna walk together, okay? You're gonna give me some options for each part of the reasoning. I'm gonna ask you to critique them, and together we're gonna walk through this tree of possibilities, you know? Is very cute, walking together, the human and the AI. Okay, and I'm not gonna extend much because I wanna go to the tree of, to the Tower of Mind. But, you know, retrieval augmented generation, this is when you combine in the same system, you know, jumping when you are solving a prompt in a question, you jump to the internet to get extra information. You get that information back from the internet and you incorporate it in the prompt. And this helps a lot. And then automatic reasoning and tool use. This is like the ChatGPT plugins. In the middle of solving a prompt, you jump to an external tool like Wolfram Alpha, for example, that is capable of doing system 2 tasks like a calculator or Wolfram Alpha. You get the response from that tool, you incorporate it into the prompt, and that helps you to solve complex questions many times. Multimodal prompting, sometimes you are gonna do chain of thought prompting, these tricks, but combining multiple modalities, images and text. And finally, you can even do things like use one of these tools like ChatGPT to find what is the perfect prompt to use it in a different tool like Midjourney to produce an image. So you can combine multiple images with these prompting tricks. That's it. 20 minutes. That's exactly what I want it to be. So now, ChatGPT has these limitations. If we look towards the future, how can we overcome them? So there are people that are working on new kinds of AI architectures. For example, Jean LeCun published this beautiful 65 pages paper, A Path Towards Autonomous Machine Intelligence, in which he proposes, at a theoretical level, a type of architecture that could actually implement these System 1 and System 2 capabilities for real in an explicit way. You see, systems like ChatGPT, they are very, very homogeneous. It's just like an end-to-end system. It doesn't have multiple modules. It's just like, you know, information in the input, information in the output, and in the middle you have these massive computations, and we're expecting all of these capabilities, System 1 and System 2, you know, from arising from all of that mess in the middle, you know. What Jean LeCun and others are saying is that, no, we are going to have to create more systematic and multi-modular architectures that are more similar to the human brain. You know, architectures that are going to have a separate memory module, you know, a separate perception module, a separate, you know, cost evaluation module, a world model module, etc., etc. No? And this is what Jean LeCun is proposing here. It's a very complex paper, and what I have done is to create this infographic, the Tower of Mind, that simplifies a lot of the important parts of this paper. And what we're going to do in the final part of this presentation is to walk together through the Tower of Mind to understand a little bit this proposed architecture that could solve the limitations of ChatGPT. So let's go for it. Okay, first of all, a summary of System 1, System 2. Remember, you want to learn a new response pattern to solve a new scenario. You activate System 2. System 2 by default is not active. You activate it at a time. And sequentially, consciously paying attention, you find the steps of a new algorithm to solve that situation. Now, that's expensive. So because it's expensive, then you transfer it from System 2 to System 1. And System 1 is very fast, it's very cheap, it's always active, it's always on, you know, and it allows you to very quickly map a state of the world or perception to action very quickly. So at the bottom of the tower, we have an ocean. The ocean represents all the world around you, all the information, all the complexity. All that complexity doesn't fit into your head. It doesn't fit. Okay. So you have to pass it through that green module at the bottom that says ENC from encoder. Okay. You have to encode all of that complexity through your eyes, through your ears. You know, you have to encode it. You have to compress it. You have to simplify it. You have to abstract it. And you have to basically produce an abstracted representation of the state of the world, encode it from all of that perception that you have. So you take it from the bottom of the tower and you bring it up and up in the tower, and you make it more abstract, more simplified. That's all the part of the perception. Huh? Okay, and now we're going to start walking from the very top of the tower, from the top to the bottom, to understand how in this new architecture, System 2 and System 1 capabilities could function. Okay, and in this infographic, I'm making all the time a comparison between human beings and AI in the very same infographic. You know, obviously, we don't know if AIs are going to have consciousness or not, but in this case, this horizontal line would separate the conscious from the subconscious. And again, we don't know if AI is going to have or not consciousness. But in this case, we are more referring to the human. So above that line, we see these comical texts that what they are expressing is like, okay, in our conscious mind, we believe that we are really, really in charge of this whole tower. That's what we believe. I am in charge of this tower. I'm in charge of all of this mess down below. But the reality, as we know, is very different. The reality is that experts tell us that every day we take 30,000 decisions. You know, a decision can be like, you know, what to say, how to move, where to look, anything can be a decision, 30,000 decisions, and we are only conscious of 0.24% of them only. So the reality is that most of what's happening in that tower is subconscious. We are not aware of it. So then at the top, we have attention, the attention mechanisms. When we want to use System 2, when we want to learn a new algorithm, we have to pay attention to the context, to the situation, to perform that optimization algorithm. So this is the lighthouse of attention. Of course, nowadays we have the transformers architecture that has pioneered attention mechanisms. So that's the attention, the very important attention capability. Now, a little bit down below, we have the top of abstraction at the top of the tower. So again, at the bottom of the tower is the ocean of complexity. We encode it and gradually bring it up the tower. So at the bottom of the tower is, for example, the specific details of a flower, the specific details of a specific flower. And at the top of the tower is the word flower, human language, that is the top of abstraction. The word flower represents every possible flower in the universe. You know? And at the bottom is one specific flower. Okay, below we have the goals. So both human beings and AIs, and in this AI architecture that Jean LeCun proposes, the AIs are going to have goals. So a goal could be, I want to walk to a supermarket. I want to learn this piano piece. I want to stand up from the sofa. Whatever, we have goals, you know. And below we have a module that Jean LeCun says is the configurator. The configurator is a module that is going to be in charge of tweaking all the parameters of the different modules of the architecture in response to the specific goals that we have. Okay, and now we go to the important part. We're going to see exactly how System 2 would work in this proposed future architecture that would solve the limitations of ChatGPT. So look, most important thing to learn, to understand is that what System 2 is going to try to do in this AI architecture is going to try to find what is going to be the optimum sequence of actions that are basically going to decrease the distance between where I am now and the goal that I have. I have a certain goal. We're going to put the example of the AI wants to play a piano piece. Okay, that's the goal. The AI wants to play a piano piece. Okay, so I want to find the optimum sequence of actions that are going to take me to that goal. And the most important thing, Jean LeCun tells us that we don't have just one goal. This is going to be a hierarchical architecture at different levels of temporal abstraction. What does this mean? If I have a goal, like I want to learn to play this piano piece, that is the main goal, but I can subdivide this goal into sub-goals. For example, first I want to learn the first part of the piano piece, then the second part, and the third part. Now I can take one of those sub-parts, the first part of the piano piece, and subdivide it again. First, I want to learn the melody, then I want to learn the bass, the instrumentation, blah, blah. So there are many different levels of temporal abstraction in a hierarchy. And when we do this optimization process to find the optimum sequence of actions to fulfill the goal, we're going to do it simultaneously at different levels of abstraction. Now, in this infographic, I am showing you a couple of levels of abstraction of this System 2 execution. Let me now explain it step by step. At the very left, you can read Actor 1, bottom on the left, Actor 1. The actor is a module of this architecture, as explains Jean LeCun, that is going to be in charge of proposing a sequence of actions. After it has learned, sending those actions to the actuators of the creature of the system. And the actor is going to have a couple of modules. One of them is called the action optimizer. Okay, so what's going to do the action optimizer? First of all, the actor is going to propose a sequence of actions, and at the beginning they are going to be really bad. It's like the AI is going to try to play the piano piece, and it's going to be a disaster. But then the actor is going to use the model of the world. Remember, we said the importance of the model of the world. Okay, so this architecture is going to have a model of the world that is like a simplified representation of how the model works. Okay, and this model of the world has the capability of predicting what's going to be from the current state of the world, what's going to be the next state of the world. And after you do these actions, what's going to be the consequence of taking these actions, things like that. So what we're going to do is we're going to take the first action proposed by the actor, and we're going to pass it to basically the action to the predictive system of the world model, and that predictive system is going to take the current state of the world plus the action proposed by the actor, and it's going to predict what's going to be the next state of the world. It's a prediction, it's a simulation. Okay, and then we're going to do the same thing over and over. Now the predictive system is going to take the new state of the world that was predicted plus the next action proposed by the actor, and it's going to predict what's going to be the consequence, the next state of the world after that, and over and over. Now we're going to take that newly predicted state of the world plus the next action proposed by the actor to predict yet the next state of the world. So we are simulating, we are predicting, the consequence of taking those actions. Now there is only one step left. We have a goal, and we have a series of proposed actions and the predicted consequence of taking them. But how are we going to evaluate how far we are from our goal? So for that, we have another module in this architecture, Jean Lecan explains, that is the cost module. And these, by the way, the white circles at the bottom, the white circles with yellow edges are the proposed actions. The purple circles above, the purple circles with white edges are the predictions of the world model. And the fuchsia pink rectangles are the cost module executions. And the cost module has two parts. An intrinsic cost module that is in charge of estimating our level of comfort. It's an energy or a cost that estimates how far we are from our ideal comfort in terms of our needs related to pain or pleasure, etc., or specific goals like playing a piano piece. And then we have also a critic module. This is very important. Why? Because remember, we are simulating. The whole point of a model of the world is that if you want to find the optimum actions to drive a car, for example, you don't want to, or to play a piano piece, you don't want to do trial and error all the time in the real world. You don't wanna throw your car through a cliff to see if that works well or not, because that's very dangerous. You want to simulate that in your mind based on your knowledge. And because you are simulating, you cannot know the real cost of taking an action. So you have to predict it. And the critic module in the cost module is in charge of predicting the potential cost of taking an action, okay, of a new state of the world. And later we will see how we train it. And this is everything, because look at this now. You propose a sequence of actions. The model of the world predicts the consequences of taking those actions, and the cost modules predict what's going to be the cost of, executing each of those transitions after you take an action. And now you sum all of those costs, and you obtain a final cost of taking all of that sequence of actions. And now all we have to do is to do an optimization process, to iterate, to take the action optimizer module of the actor and over and over and over and over, tweak that sequence of actions in the direction that is going to minimize the cost, that is going to minimize the distance between where we are in terms of comfort, in terms of distance to our goal, and where we want to be. because that's what every living creature or AI is going to want as a final objective, to minimize the cost, to minimize the energy, to minimize the difference between our current level of comfort and where we want to be in terms of comfort and in terms of our goals and stuff. So that optimization process can be of different kinds in regards to the specific, depending on how continuous and differentiable is going to be the path that goes from the actions through the world model to the cost. If that connection between the actions, the world model, and the cost is very continuous and differentiable, then we could use gradient-based algorithms like backpropagation. But if that space is very discontinuous, then we would have to use gradient-free algorithms like dynamic programming, heuristic search, combinatorial optimization, etc., etc. Okay, so once we have finished this iteration, remember, at multiple temporal levels of abstraction in a hierarchical way, once we have finished to iterate through this optimization process, we will have learned the optimum sequence of actions in this case, playing this piano piece for this AI system. But remember, the problem with system 2 is that it's very expensive. So what we want to do is, once we learn some actions, we want to automate them. We want to make them automatic. We want to transfer them to system 1. So how does that work? Here we are in the final part of the tower. So the actor module has another part of it that is what we call the policy modules. These yellow triangles that you see at the bottom are policy modules. What is a policy module? A policy module is a module in this AI architecture that is able to map from a state of the world to an action very fast. It's system 1. So a state of the world that is an abstraction of our perception to an action or a sequence of actions. And we can have multiple of these policy modules that are going to map between different states of the world automatically to different actions. System 1, very fast, very cheap. And now the question is, how do we transfer the learning from system 2 to these policy modules of system 1? Very simple. At the top of this slide, you can see the white circles with yellow edges that are the actions that were learned by system 2. And below, you can see the yellow triangles that are the policy modules of system 1 that we want to train. And in the middle between both, we have these light blue squares with a D. What they represent, those light blue squares, is the difference between the action proposed by system 2 and the action that is the output of the policy module of system 1. And what we want to do again is an optimization process that is going to gradually decrease the difference between the action learned and the action proposed by the automatic system 1 policy modules. And we do that over and over and over. And when we finish to optimize that, the automatic policy modules of system 1 are automatically producing, in response to a certain state of the world, producing the same actions that we learned in system 2. You will see that there are some brown arrows that go from the top to the policy modules. So the policy module is taking as input the same state of the world that was being used in system 2, and then it's connected to the optimizer that decreases the distance between the action learned in system 2 and the action that the policy module produces. And this is going to automate completely that connection between the same state of the world and the same action that was learned by system 2. And that's all about it. And now the final thing, we're going very well, 36 minutes. The final thing is, at the left of this slide, we have the short-term memory module. You see, ChatGPT doesn't have a dedicated memory module, but this AI architecture would have it. It would have a short-term memory module that would be in charge of storing pairs of states of the world and costs. And why is this important? Because remember, when we are trying to learn a new algorithm with system 2, we propose a sequence of actions, we predict the consequence of those actions, and we predict the cost that they have. But to predict the cost, how do we do it? We have the critic module, but we have to train the critic module. So how do we train it? We go to the memory, and from the memory, we get state of the world, and we try to predict what would be the cost associated to that state of the world, and we compare it with the real cost that is also in the memory, because in the memory we are storing pairs of states of the world and real intrinsic costs. So we can use that to train the critic. Basically, we optimize, we iterate again, okay, and we try to decrease the distance between the prediction, the cost prediction of the critic module in the cost module, and the real intrinsic cost that we had stored in memory. And in this way, we improve over and over in an iterative way the predictions of the critic module. This is what would be done in this architecture. And that's about it, okay? This is like the most important part of the academic paper. And this is just what I want you to get from this is that, again, ChatGPT works very well, but ChatGPT is like this giant system one cooking pot where you give something in the input and it just cooks and mixes and recombines with all of these massive amounts of parameters, and you are hoping that it's going to be able to do everything. But what we can see is that it's very good, but it's very brittle and fragile as well. It can hallucinate, it can go into contradictions, it's very unpredictable. And what we want towards the future, okay, is more something like this. Is more something more similar to how the human brain works. So let's go back to this one. Where we have different modules. We have a world model, we have a short-term memory module, we have a cost module, we have a perception module, a configurator, and an actor that is in charge of proposing actions for system 2 and also driving the policy modules of system 1, etc., etc. And, you know, an architecture that in a systematic way allows you to implement system 2 algorithmic processes to learn the steps to solve new situations, and system 1 capabilities that allow you to very quickly map from perception to action, and ways of transferring the learnings from system 2 to system 1. All of that surrounded by the right infrastructure with memory, with a configurator, with perception module, etc., etc. Okay. If you want to explore deeper this architecture, I have the article that is free to access at medium.com/@Ideami. I have many articles. Some of them are behind the paywall, but this one is completely free and you can access it there. And that's it. I think it's been very precise. 40 minutes. Those are my links. Also, this movie that we are producing now, that is one of the first movies in the world about prompt engineering and that uses generative AI techniques. You can watch the trailer at on the bottom left at ideami.com/H77. There is also an associated free article as well. And yeah, thank you very much. It's been a pleasure.
Wow, Javier, fantastic. That was fascinating. And do you know, one thing that struck me while you were talking about it, particularly about the model of how generative AI tools can work better, is you just go back to nature and see how the real mind works. And if you extrapolate out the main functions of the real mind and we can apply that to generative AI, then it's just going to be a lot more effective. Like nature has already done this, so we should mimic nature as closely as possible. Yeah, I agree. I mean, you know, we don't have to necessarily copy like with birds and the planes and the birds, right? We don't have to copy it exactly, but certainly we can find a lot of inspiration because it's had billions of years to evolve those capabilities. Some things will be completely different, you know, but certainly we have to. There is a lot of hype right now, of course, about AI, and if we look at it carefully, we will become conscious of the current limitations that are a lot. And to solve those limitations, we can definitely find inspiration in the human brain and in the human mind. There are a lot of fascinating things about this, like the way the human brain uses sparsity in the activations and the connections between neurons, the energy efficiency, the fact that the brain only uses 20 watts of power, for example. There are a lot of things. The fact that it can forget things as well, because you've got a lot of bad data that it needs to forget. Yeah, that's important. Exactly. It can create new neurons, but it can eliminate connections. It can inhibit connections. It can
Absolutely. This is, and when we go to sleep, one of the theories, of course, is that we are trimming those interconnections as well. And
Right.
nothing of this is happening. Our artificial networks at the moment, they are very rigid. We don't have continuous learning, and they are very fixed and very rigid. So to all the people that are, listening, and I want to also transmit this message that we are still at the beginning. It's very exciting. We are in a very historical moment, the only time in human history in which we are transitioning to reproduce and replicate our thinking and our mind. So it's a historical moment. It's extremely enthusiastic, extremely inspiring and exciting. But make no mistake, we're still, even though things have accelerated so much in the last year or two, we're still at the beginning. Now, it's an incredible beginning, because what is funny, of course, is that the beginning is already surpassing us. The beginning is already becoming superhuman in many levels. But, oh, man, this is still going to grow so much further.
Mohammed, do you want to make some comments?
Yeah, thank you, Javier. It was a wonderful session. It
Thank
really
you.
opened my mind a lot to understand how this actually working. And you're correct. You're correct. That's why they tell you need to be more specific if you need to get proper outputs, and the instructions and the expectations and all the constraints that is there. More the information is there for these tools, the better the information will happen. And
Yeah.
one thing I just wanted to ask, maybe there are some questions in the chat, but see these things that we are mentioning, generative AI, the technologies that are behind this is a little bit complicated, and many times people want to understand this in a better way, like how these things really work, the techniques behind these. Because if you are understanding the techniques, how it is working, like the way you explain, then only you will be able to use the system or design the system in a proper way. So what are the just few, if you can say, few technologies or things or technologies, or I can say techniques that we should learn to incorporate and appreciate these technologies in a better way? Mostly I'm talking about the generative AI space.
Yeah, no, great question. Great question. I mean, AI is a huge space, and you can approach it through many different areas and in many different ways. What I would say that is definitely useful is to do a combination, because you have touched a very important thing. There is a danger when you are learning AI of going either too shallow or too deep. Okay. And they are probably both equally dangerous, in the sense that if you go too shallow, if all the time everything that you're doing is just like, doing experiments with Midjourney and ChatGPT, and you just never go into the technical how it works inside, you are never really gonna have the capability to do your own proposals and to drive your own projects. Yeah, so that's the danger in the shallow. But there is also the danger in the deep, because there is so much depth in AI in terms of mathematics and statistics, and the connections with physics, with neuroscience, the connections with algorithmic processes, with a million things. So you can also go like super deep and forget about the practical applications as well. So what I would say that is definitely useful is to do a combination of both things. I would say try to definitely build things, even simple things, from first principles. I mean, most of you will know who Karpathy is. Yeah, Karpathy. So Karpathy is one of the most talented researchers. He has been the director of AI in Tesla, in the Elon Musk company, until recently. Then he left. Andrei Karpathy. And Karpathy, for example, is a genius at this. He has a lot of beautiful videos and tutorials in which from very first principles. He published one recently, right, to build, I think, HLRF with an LLM in a very simplified fashion, from first principles, from just the basic code, and I definitely recommend this. I definitely recommend that you look at this type of tutorials and projects where, in a very simple way, programming from first principles, from zero, you build some very simplified versions of these systems. This is super useful. But at the same time, I also recommend that you experiment as much as possible with the actual tools that people have produced, from Midjourney to all the others, because we are in a very interesting time now in which a lot of people are starting to sort of copy each other and just build the same thing that other people are doing. But really what you have to try to do is to play with all the ecosystem and try to find a niche, try to find your own niche, a new niche, where you can come up with a new kind of interface or solution or combination of AI tools, to produce something useful, And this is going to come again from combining a lot of experimentation with a very wide range of tools, but also by building things from first principles, by understanding the way the technology is working below as well.
Yeah, thank you, Patrick.
Yes.
So there are some questions in the chat. I will just quickly
Let's see.
read it.
Chat.
So there is a question from Albuk. He's asking about like the same thing that you told, but he's asking about the coding part. Which part would you start coding first?
Okay.
Out of this whole Tower of a Mind model, I mean,
Yeah.
is somebody actually trying to build it at the moment to actually create this thing that can be, so it's useful for people that we can play with it, or
To build exactly what?
the whole Tower of a Mind, the model itself, is somebody, this is an architecture, obviously. Which,
okay, you mean in relation to the architecture that I explained today?
Yeah, yeah.
Okay, no, not yet,
right.
yet, because so this is a theoretical paper that is basically like anticipating the type of AI architecture that we may have in a few years. Okay.
Okay.
But Jean LeCun itself, the three godfathers of AI, Jeff Hinton, Joshua Bengio, Jean LeCun is one of the three godfathers. So Jean LeCun admits in the paper, and this is a very long paper, 65 pages, but it admits that there are some parts of this architecture that he has no idea how to create yet. Okay.
Right. Okay.
So there are. This is as if we were anticipating what's going to be the rocket, the space rocket, in a few years.
It's like Jules Verne, isn't it?
Yeah. And there are some technical problems that we still don't know how to solve of this new. We know that this type of architecture would solve the problems that ChatGPT has, but we still don't know how to build it completely, because if we knew it, they would be building it already, of course.
Yeah,
they would be building it already. But I think it's very exciting because to think about this new type of architecture, it makes us more realistic and it makes us more conscious of what's possible and what's not possible today, and where we're moving towards.
We have to dream, don't we? We have to.
We have to dream. We have to dream. And we have to dream, and we will be surprised. You know that even the researchers that built ChatGPT, they did not expect it to work so well. Nobody did. And when we were building Geniverse, we also didn't expect things to move so fast. So everybody's getting surprised. And my prediction is that we're going to see that type of architecture becoming a reality sooner than we expect. Okay, so what was the question of... it was about the coding. Yeah, here it is. As a programmer, which part would you start coding first? Blah, blah, blah. Thank you for representing the Tower of Mind architecture is very complex. Okay, you are referring, Albuk, you are referring to the actual Tower of Mind architecture. Well, I will tell you that the most critical part of the whole architecture is the world model, okay? And in this 65 pages paper, Jean LeCun proposes something called Joint Embedding Predictive Architecture, JEPA. Okay, joint embedding, and a big part of the paper is dedicated to describing how this architecture, that is not the whole tower, is just the world model. Remember, the world model is in charge of predicting what's going to be the next state of the world from the current one, what's going to be the consequence of taking some actions, the new state of the world after taking some actions, and what's going to be, missing information in your perception, things like that. It's able to simulate and predict all of those things and more, So that would be the first thing you want to master and you want to program, is a great model of the world. We humans have a great model of the world, I mean, I am right now looking at the screen, and I can predict where my hand is going to be next. I can predict if I look that way, what I'm going to see, whatever. And if my prediction doesn't match with my perception, I'm going to be very alerted. There's going to be a big error signal, and I'm going to be like, whoa, what the hell is going on? You know. But most times my model of the world works very well. Most times I'm not surprised. In fact, one of the imperatives of the very famous active inference theory of Carl Friston is that every living creature is trying to minimize surprise. That's like our survival imperative, minimize surprise. And for that, we need a great model of the world, because if we have a great model of the world, most times we are not going to be surprised. Most times when I look this way, when I moved my glass, I know where the glass is going to be. I know the glass is not going to jump something to another place. But if the glass suddenly jumps to another place, that's going to create a big error signal. And my brain is going to go into, system two, analyzing what the hell is going on here. I have to learn that now the glass is fly or something, you know? But most times this doesn't happen. So the first thing you want to program is a great model of the world. And if you want to go into this paper, I think you share the link, you will find this joint embedding predictive architecture proposed by Jean LeCun with all the details of how this architecture would work, and then somebody can try to program it, you know. And obviously there are people right now trying to program that joint embedding predictive architecture. Yeah.
I have to start reading then.
Yeah. I think Adil has shared the link. Yeah, it is a.
Yeah, you should definitely share the link to this paper. It's an amazing paper. I mean, honestly, if you read this paper, it's a 60 pages paper. It gives you a fantastic overview of where we're moving towards.
Yeah, awesome.
Okay,
more questions? Let's see.
I think Azam is asking about will we be expecting a software like ChatGPT that uses the Tower of Mind architecture in the future, where everyone can use and test? I think.
Yeah, I mean, I have no doubt that we're going to see ChatGPT-like systems and other types of systems that are going to use this type of architecture that we see in the Tower of Mind. It's not going to happen soon, okay? Because again, there are technical problems that we still have to solve to be able to do such a. Because I will tell you, when we have an architecture of the type that we show in the Tower of Mind slides, we will be very close to how the human brain works, you know, because we will have proper system 1 and system 2 capabilities. That is what we humans are doing, okay? We humans, you know, right now, I'm talking to you. All of this is system 1, you know, the way my arms are moving, I don't have to pay attention. It's automatic. This is system 1, you know. But now when I focus consciously with attention on you, I'm using my language, this is system 2, of course. And if I have to later learn something new, it's also going to be system 2. So yes, we will have that. It's not going to happen very soon, but I do predict that within the next decade and before, okay, basically within the next few years, we are definitely going to have this type of Tower of Mind architecture in place within a few years, and we could be surprised. It could be much earlier. I mean, let's remember that Jean LeCun is one of the 3 most important people in the world in AI, proposed this already quite a few months ago. So this means that for sure a lot of people are working on it right now. So we could be surprised. You know, we could be surprised, and in a year or 2 we could have something of this kind, or in a year or 2, or maybe in 4 or 5. Let's see. Yeah.
Would you describe the model as a bottom-up model, like the Tower of Mind? You have to build a model of the world at the bottom in order to then add layers of abstraction on top, as you said, before you got to something you can actually utilize.
Well, the model
it's a
of
bottom-up model, yeah? Or would you describe it like that?
I mean, if we go back to the slide, so let me wait.
I mean, you can't model the world with one equation, for example. You have to.
Yeah, I mean, the way it works is that the model of the world is really at the top part of the tower, because because you know, again, you cannot put into your head all the complexity of the world. It doesn't fit.
Yeah.
So you have to compress it and abstract it. So a model of the world is a simplified, abstracted representation of how the world works. So by itself, it's a latent space that is compressed and abstracted. So it's a set of abstractions, basically, the model of the world.
Sorry, the abstractions come from a massive interaction of massive parallel processes.
The abstractions come bottom up
from
because
the bottom up. Yeah, exactly.
Because at the bottom of the slide here we have these green modules, the encoders. Okay, so the green modules are taking our perception. Okay, and the perception is very detailed and everything, and they are encoding it, they are compressing it, and they are driving it up the tower. So from the bottom to the up. From the bottom to the up.
There's a guy I remember reading about. I don't know. Remember if you know about him? He's a British guy called Stephen Grand. He was writing about this 20, 30 years ago, where he said you can never model the world from the top down. You've got to start by trying to model the most simplest systems.
Yes.
And then simulate them in a massively parallel computational way. And then the interactions that are happening between them is what builds the complexity layer upon layer to the top. And
I mean, a very useful way to think about it is thinking of kids and babies, and the way to ask, kids and babies are interacting with the world. Like their world model is very bad at the beginning, right? It's very simple, and they touch things, they touch and they lick and they whatever. And that perception, right, it starts to be abstracted up the tower, and it starts to create a simple world model at the beginning. Well, things move, and things.
He actually built a robot chimpanzee, and he was teaching it at the very basic things, and then he just let it go to learn and learn and learn, and try to build abstractions upon abstractions to do more sophisticated things. And he reckoned he got it up to about a kid of about 3 or 4 year old intelligence, but I think he ran out of funding.
That's it.
That's
it. And the interesting thing is that as we get older, our models of the world become, more richer, and then what separates? The interesting thing is what separates. We can think also of the process of thinking as the process of moving through those maps. Let's say those abstract maps of the model of the world, and the difference between an Einstein or a Marie Curie and any of us, let's say, is the quality of those maps, the quality of those abstractions, the quality of those world models, which is quite a beautiful thing to think about, also. It's like if you have a map of Europe in paper again, you can have many types of maps of Europe in a paper to simplify all the complexity of the surface of Europe. But some of those maps can be a complete mess that you don't understand anything. And so you are looking for this is another interesting thing of the active inference theory of Carl Friston. You are looking for a good compromise between simplicity and accuracy. You don't want a very complex model of the world, because a very complex model of the world spends a lot of energy, requires a lot of computation, and it just complicates everything. You want it to be as simple as possible while still being as accurate as possible. You want to balance those. It's like a good map of Europe. You want it to have enough information without being overly complex, being accurate enough, but being simple enough. So that's the balance that you, as an organism, you are trying to get with a model of the world as well.
Yes. Yeah. Okay.
Nice. Any other question? Let's see. Any other question?
There is a question, but I know it is not related to tower of mind, but it is regarding Jeffrey Hinton's decision.
Oh yeah. Well, I thought I like Geoffrey Hinton a lot. I think he's first of all he's a genius, one of the top 3 godfathers of AI, and he's very humble as well. I think he's a really nice guy. I think he did very well because he was consequent with what he thought. If you're thinking something, you should act in proportion to how you are thinking. So he was thinking there were these dangers and acted in consequence, and I think that just makes sense. He followed his heart, basically, in that. So, at the moment in the AI community, there is a lot of division. For example, Jean LeCun says that there is not really a big danger. You shouldn't get worried. And then Geoffrey Hinton and Joshua Bengio, they say you should get very worried. There is a big danger, So imagine if at the very top, in the top 3 godfathers of AI, they don't agree. If they don't agree, there are like the 3 top. How is everybody else going to agree? Yeah. Jean LeCun, Geoffrey Hinton, and Joshua Bengio is the 3rd one, Joshua Bengio. So, there is a lot of division regarding this. Okay, who was the powerful man? Yeah, the 3rd also is Jean LeCun, Geoffrey Hinton, and the 3rd one, I'm going to write it here, is Joshua Bengio. Joshua Bengio. These are the 3 godfathers of AI, winners of the Turing Prize. That is like the Nobel Prize for computation. So, yeah. So yeah, and connected right now we have here my dear Agora Reis, a fantastic multidisciplinary artist who I was actually speaking to her recently about these concerns. You know that many people are concerned about the evolution of AI, potential dangers, and the way it's going to affect our jobs and things like that. And again, in the community, right now there is a lot of division. Some people think you shouldn't worry a lot. Some people are very worried at all levels, you know. And I think in my personal view is that, you know, I belong to the optimistic side in AI. I always did. I believe that AI can help us automate all the tasks that are boring and, you know, hard for us to do. And it can leave us more time for the things that we enjoy. But there are many risks, and you know, it's possible that things could go wrong. So what I'm trying to do personally is to push in the direction that I think is going to be beneficial for humanity, and I think we all have a responsibility to do that. Things are moving very fast, but I am hopeful because I see a lot of people working in AI ethics. I see a lot of people working in alignment, in the alignment issue. I see a lot of companies trying to take responsibility. I see a lot of governments trying to implement regulation, even though it's going to be difficult again because they could either exaggerate or they could come up short. But still they are trying, you know. So I'm hopeful, you know. Yeah. More thoughts, more comments, more questions.
So one question I wanted to ask, because many of us, as you mentioned, are worried about the future. The type of jobs are really going to change, right? This is like one of the revolutions that generative AI has got. What are the skills that now people should really focus on? Now there is a buzzword in the industry about prompt engineering. So what are your thoughts? Because coding is moving away from because of AI tools, the coding has become very much automated. There are a lot of automations that are happening, and many jobs are getting redundant. So what are the skills that the people who are there new to the industry and who want to maintain their career should focus on in the next few years?
Yeah, that's a fantastic question. Definitely prompt engineering. You mentioned prompt engineering. Our movie is about prompt engineering. Prompt engineering is going to be extremely important. Many of you probably know that Anthropic, a company bought by Google, they published the very first job role for a prompt engineer in California with a great salary. And now many other companies are already employing prompt engineers. I mean, look, in the next decade or more, we are going to coexist with these AI entities. These AI entities, remember, they have very good system one, but pretty bad system two. And what does that mean? It means that we have to guide them. They need our help. They need our guide. And that guide is the prompt engineering. It means that more and more in every field, in every company, in every group, you are going to have, you know, some humans guiding AI systems more and more. And, you know, today we have a number of AI systems in some months or years, it's going to be like exponentially larger possibilities and diversity of AI systems. And prompt engineering is not easy. Prompt engineering is an art and a science. First of all, you need to understand technical aspects in terms of engineering. How did this AI, how was it trained? With what data? With what data set? What are the strengths and the weaknesses of this AI system? But then it's also an art. When we interact with another human being, we gradually learn, you know, the ins and outs of this person, and we start to understand, oh, if I talk like this to this person, this happens, you know. Well, we have to do the same thing with the AIs, you know. We have to have this sixth sense, this art, this experience, this background, you know, to see what is the best way to get the best results from this AI system and from this AI system. That's why it's very interesting in the job requirements of an Anthropic. They didn't ask for a lot of technical knowledge or anything. No. They ask for people that had diverse experience, that were creative, that were problem solvers, you know, because prompt engineering requires depth of experience, of creativity, of problem solving. It's an art and it's a science and it's complicated. So I would encourage everybody to, first of all, to practice your prompt engineering with ChatGPT, practice your prompt engineering with Midjourney, practice your prompt engineering, with some guides around or something, etc. That definitely, for sure, in terms of skills, And the other thing that I would say is that pick the field that you are most passionate about, your job or whatever thing. You could be a psychologist, you could be a doctor, you could be an educator, like my dear Agora Reis. You could be, who is also another 1,000 things, but yeah, you could be an engineer, you could be anything, and think in what ways prompt engineering, this capability of automating your little friend. By the way, another thing that you should know is that today you are using ChatGPT, but very soon, because a lot of startups are working on it, each one of you is going to have your own LLM, personal LLM, that is going to learn about what you like, what you don't like, what you need, what you don't need, and it's going to try to help you every day. It's going to try to suggest things to you. It's going to try to help you when you need some assistance, psychological or non-psychological, whatever. There are startups working on this. This is going to happen pretty soon, But yeah, try to think what parts of that activity that you do could benefit from automating them or improving them through prompt engineering in combination with some of these tools. Because if you do that, you will be at the forefront. You will be leading that field in the coming future. And if you don't do that, if you close your doors to it, you will be left behind, like Kodak was. Kodak was the leader of photography, and digital photography appeared, and they said, we don't want to know anything. We don't want to know anything about digital photography. And what happened to Kodak? Goodbye, Kodak. Okay, so that's what you want to do. You want to jump on the wagon of prompt engineering. That's the most important part. Yeah.
Fantastic. Are there any other questions? We're getting close to the to wrapping up time, I guess.
Yeah, last minutes. Let's see if anybody else has some
any more questions from the floor.
Some challenging questions, something surprising. Surprise my world model. Ask something that I am not expecting. Okay, are you excited about your movie? Yes, very excited, because we wanted to be one of the first people making a movie about prompt engineering, and we was very tough to do it. We had to do it pretty fast. We used a lot of technology and drones as well, in a very complicated historical building. Half of the team, by the way, it was winter, last winter, half of the team got sick, and ill while we were doing the film. It was a big challenge, and we kind of survived. And now it's going well. A couple of good film festivals already are going to do premieres in September. And yeah, we're very excited. And there are different groups that are going to use the movie for education, because it's a movie that is entertaining, but at the same time, it can educate people about opportunities and risks of this technology. So some people are going to use it for education, which is exciting as well. So yeah.
So wherever you are in the world listening to this, if you have contacts who might be interested in help premiering their movie in their country, in your country,
yes,
then contact Javier directly, and I'm sure
yes,
he would be very happy to.
What does that mean, H77? Anything?
Yeah, so Amelin is referring to the very famous fairy tale of the Piper of Hamelin. I don't know if you know it. Yeah, the Piper of Hamelin, because it's all about the issue of control. We are moving towards an ecosystem where we're going to have all of these AIs trying to control each other, and we're using prompt engineering to control the AIs. So it's about control, and that's why it's the Piper of Hamelin metaphor, And 77, if you want to know what the 77 means, you have to see the movie. Because if I reveal it, I'm revealing part of the movie, so I cannot.
Spoilers.
Eventually, you will see it.
Yeah, one question from Priya. She's asking about you personally. What is the best use case you have seen in generative AI?
Oh, wow. That's there are so many. There are like infinite use cases. A very inspiring case is that in medicine, sometimes you want to use artificial intelligence to predict if there is, for example, a disease in some scan or something, but you don't have enough data to train the AI. And the interesting thing is that you can use generative AI itself to produce synthetic data to increase the size of the data sets that you then use to train the AI to find the disease in the data. That's a very interesting recursive sort of use of generative AI that is beautiful because it's connected with health. Yeah. blah, blah, blah. Another very interesting use that I think you have seen in the news is that they are using generative. Well, this is not really generative AI. It is the combination. Actually, they have used AI to interpret the brain waves, but also generative AI to try to reproduce what the interpretation refers to in terms of what you are thinking about visually, and then they sort of like regenerate it. Yeah, somebody here saw it, But there are so many. I will tell you another one that is controversial. If you want me to finish in a controversial way, it's a.
We like controversy, Kevin.
No, I mean, it's not really controversial, but I know a lot of people that are using AI and ChatGPT now to tell ChatGPT about their concerns and conflicts, and kind of like a psychologist, right? Instead of a therapist. They are using it as a therapist. And so there is this very interesting paradox about ChatGPT, okay? So we used to think that systems like ChatGPT, they would be really, really good at facts, like at rigid information, facts. And in fact, they are really bad at it. They many times hallucinate and they lie. And we used to think they would be really disastrous at emotional, and like stuff like that. And they're actually really good at it. It's a paradox. It's like the complete opposite. And why are they good at that? The reason why they are good at that is because if you think about it, ChatGPT has all the conversations of all the top experts, psychologists, and therapists in the planet that are on the internet. It has all of that. So whatever you tell it of a conflict,
for sure, some company's going to be selling some kind of companion robot powered by ChatGPT with voice translation thing, and as your companion to
yeah, that's gonna happen. Now, at the same time, and in parallel to that, I do want to say that I'm in a very interesting situation because I am a technologist and an evangelist for AI, but I'm an artist as well. I'm a creative, and I want to say that I do a lot of talk as well and activities to defend and protect above all the activities and the creativity and the jobs and everything of humans. We have to be careful. We have to be careful because AI is like a steamroller, So we are trying, a lot of us are trying to drive this revolution responsibly. And in fact, there is a movement that you have heard about that is responsible AI. Is something that comes about a lot, and I want to finish actually with a message of tranquility for people here as well. A lot of people, again, are worried about jobs and things like that. But again, first of all, there is an inertia. There is a lot of weight from everything that is right now in the market. So things in that sense, in the sense of jobs, they are not going to change as fast as some people fear, okay? Because of the inertia. So things are going to go slower than people think. And second, you are going to have plenty of time. People are going to have plenty of time to adapt. You just have to, again, don't be Kodak. That's all. Yeah. Don't be Kodak, okay? Yeah. Just don't be Kodak, okay? Just don't look at AI like your enemy. Look at AI like, your companion that can take a lot of weight off your shoulders and help make your life more beautiful and relaxed. So somebody says, we developed our own LLM as a creator of... What would you say we need to be mindful of from an ethical and don't be Kodak, yes, from an ethical and business point of view? Oh, that's a long one. That's a long one. I mean, first of all, from an ethical and business point of view, there is a lot of drive right now in people developing LLMs regarding the source of the data that you are using to train these LLMs. Okay, so probably some of you know about what is the name of this? Yannick Kilcher drove this open source LLM recently, and they did a very beautiful drive around the world. And basically, all the data that was used to train that LLM was provided by a large community of users around the world, completely free, volunteered, So yeah, you need to train your systems with ethical data, with data that you have the rights of that data, from a community or for something. That's definitely super important, And then, business point of view, from a business point of view, yeah, I think the most important aspect regarding all of this is the IP. Really, is the IP from all sides. From the side of training the system, from the side of distributing the results, etc., etc. But if you train your systems with data that that you own, and that is ethical, really that is the hardest part. The rest should be easier from there. Yeah. And congratulations for developing your own LLM. That's no easy feat. Very good. Yes. So, my friends, anything else?
Yeah.
Let's see.
That's
We've
it.
taken
Yeah,
up a
I
lot of
think-
your time, Javier. I think we ought to let you rest.
It's been very exciting. I like, don't be Kodak. I think that's a nice mantra.
Very
Don't
good.
be Kodak. Poor Kodak people. The
Yes.
reputation has reached even today. How can we learn more about ethics and regulation?
Uh-huh.
Yeah. Well, first of all, for all of you that are in Twitter, you know that the AI community is very, very active in Twitter. Yeah. There are a lot of fantastic people driving active newsletters, letters connected through Twitter. Yeah, I could give you a list of some of the best people driving this news in Twitter. But anyway, Twitter or off Twitter. And anyway, it's not Twitter anymore, is it? Anyway, yeah,
Yes.
ethics and regulation. That's so confusing, man. This X thing is so confusing.
It is.
Anyway, oh my goodness. Anyway, I hope that at least they reach Mars for real. Anyway, so ethics and regulation. Yeah. I would say the internet is really full of information about it. I mean, keep alert with what's happening with the European AI Act, because it's going to be taken as an inspiration and as an example by other regulatory bodies around the world. So it's good to be aware of. You can go to the websites of the European Union and see the evolution of this process. But to be honest, the best way is with these online influencers. And most AI online influencers are at Twitter or X, or whatever you want to call it. So yeah, I could share some of them with you guys, and you can pass them around. Yeah.
Thank you.
Okay.
Well, I guess thank you so much, Javier, for your time.
Very
It's
welcome.
been really amazing talk, and we appreciate
a
the
pleasure.
time. What can we say? I just thank you from the bottom of my heart. So I hope, maybe one day in 6 months or something, you can come back and do another
hopefully,
one for us.
yeah,
and if anybody, maybe we can get you over to Dubai, and we can help you, link you into the government here, and do some projects, and we'll work on that and see what we can do.
Yeah, maybe we bring the movie as well.
Yeah,
one day to Dubai.
that's the thing. I think that definitely there's an opportunity there to helping bring the movie to Dubai. So we need to.
Yeah. Share the trailer in the group as well, and you have the links as well. I think.
Yes,
other
I
links
posted them right at the beginning of what's in the meeting. Everything's there in the text, but I will.
Yeah.
Repost the movie trailer right now.
So it was very good. Thank you for your time. Personally,
Thank you very
also, it
much.
was very, very mind awakening, right? So much is going on, but we need to understand the
Yes.
details and how
Together we will drive this revolution in the right way, my friends. Together we will make it.
Yes,
Exactly.
Thank you.
Thank you very much. All the
Have
best.
a great day.
Take
See
care.
you.
Cheers. Bye.
All the best. Let's stop sharing here, and all the best.
Take care. Thank you.
So, guys, I'll just take 5 minutes of your time. I know it's over past the time. I'll just take 5 minutes. If you guys can wait, it would be nice. And talk about the next week activities very quickly. I know we had a very special session today and a lot of knowledge, and we did not want to stop him and get all the information that it's good, right? This tower of mind concept in these new technologies. So I'm just sharing my screen just quickly. If you can just say if you can see the screen. So I'll just move to next week events. All the details are there in our NAS community page. I don't want to take much of your time. We have our SQL 2 hours workshop with one of the collaborators from TechNesh. That is for anyone who wants to know about SQL, please join about this. Next week, we have one more guest speaker from AWS. He's one of the senior developer advocate, and he's going to talk about data engineering, right? Because data, as we all know, the core of data science and AI is data, and we need to understand what actually is data engineering and how we can use it as a learner who wants to build their career, or as a business who is wanting to make sure that the data is proper, like the LLMs that you're creating. How will you get the data all there? And it's very, very important. And we have Faz, he's one of the advocates of AWS, and he's our guest speaker for next week. These all the details are there in our nas.io/artificial intelligence/events. Also, we all know that one thing that is very important is LangChain for connecting all these LLMs, and we are planning to have a free workshop, 1 hour quick workshop on how we can get started on LangChain. What are the resources that are available that we can start using, and how we can use LangChain and use it to connect with OpenAI and do simple operations that are there. So this is a workshop. All the events that I'm showing you, all the 5 events that are there is there in our event page. And also we have Hemant, he's our career coach, who's going to talk about how to use Microsoft OneNote in a you can say an efficient way for increasing your productivity. So now coming to this week's challenge, I wish if Krishna is there on the call, congratulations, Krishna. I will, for the winning the weekly Python challenge, we will get in touch with you personally to share you 1-month membership of our AI community. So this is it. I don't want to take much of your time. Anything else with Patrick before we want to end the?
No, I think you know the Javier's presentation was excellent, and I'm sure everybody enjoyed it. So looking forward to the next one.
Yes, so I'll just put in the chat. Someone is asking, they're not part of the group. I'll just put it, and all the links that we mentioned, we will personally reach out to Javier and get the Twitter influencers that he's talking about, generative AI ethics specifically, to follow on Twitter. I don't know the names exactly, but we will get the names. Anika asked, and we'll put it on the our WhatsApp community group, who are the top influencers, and the top 3 names we already put on the chat. The top 3 AI godfathers that he was mentioning, it is there on the chat. If you're connected on your system, there is an option called save chat. You can save the chat. Whatever conversation has happened, you can keep it with you. And also the recording will be available by the team in a day or so, and all the details will be updated in the platform. Thank you everyone for joining. It is almost 1 hour 40 minutes with us, and look forward to you in the next community meetup. Have a great evening.
Bye.
Bye-bye.